Properties of Quadrilaterals, Video 1, Unit 4. So in this first section, we're looking at polygons, which are something you've seen since elementary school. But we're going to be a little more specific when we're talking about polygons and how we can name them. So the first thing is convex and concave polygons. This is best seen just by looking at the picture. Here we have a convex polygon, and the best way to look at it is we can draw this straight line that goes right in, and because it has to be straight, it has to come right back out. There's no way that it can go in and go back out and then come back in. And so that's what a concave polygon is, and how it's different is you can draw this line that goes in and it comes right back out, but then it can go back in again, even though it's straight. So it has this funky angle in here that's bigger than 180. And that's what messes up the interior angle sum and the exterior angle sum. So when we're talking about convex polygons, that's when we can use the interior angle sum theorem, the exterior angle sum theorem, and things like that. Convex is when it has that dent, or it has that little cave, and those things don't work. So it's just another way to name a polygon. So if we look at these examples down here, we see that this one right here, it looks like a regular polygon. I can draw any sort of line through it, and it's always going to go only in one time. So we know that that one is convex. There's no dents. This one right here, I see the same thing. It's also convex, no dents. If I do the line test, it's not going to come back in a second time. This one, I'm seeing that it does have this weird dent, and if I try and draw the line, I see I can, and so I see it must be concave. It has that little cave or dent in it. This one down here, all the angles look less than 180 on the inside, and I can't think of how I could draw that line, so this one must be convex, and this one is a little strange in that it does seem to have these two dents on the side, and if I think of this as one shape, I can draw this line right here that goes in twice, which shows me that this must be concave. Scrolling down here, we have some review topics, which you've seen before, but they're key things, so we're just going to go over them one more time. So we have the distance formula, which, if we remember, is using Pythagorean theorem to find the distance between 2 points. So if we have 2 points, we'd subtract the x's. And the reason we do x2 and x1 is just to make sure we do it in the same order in both sides. So if we do x2 minus x1, we got to do y2 minus y1 squared, and that's all under the square root. And so it's like if we're thinking about if this is our x1, y1, and this is our x2, y2 point, and we're trying to find the distance, or like the length of this line. What we're really thinking about is that, well, we find the length of this, and then we find the length of this, and then we can find that hypotenuse. And so the length of the red is, well, they're thinking about this in our x-plane, so we think about x2 minus x1, and then we think about the length of the blue line. We're thinking about, well, this is y2 minus y1, or we could have done, this kind of flipped, like x1 minus x2 and y1 minus y2, and if we square both those sides, we'll get the hypotenuse, and so that's why we do the square root for the distance formula. Midpoint formula, we're essentially trying to find the point right in between those two lines, and so all we want to do is find halfway on each side, because we know it needs to be right in the middle, and so we're thinking about it's almost like we're finding an average. Like we know we have 2, add them and divide by 2, and you're finding a coordinate point, so that's why we do x1 plus x2 divided by 2 and y1 plus y2 divided by 2 to get that midpoint. And the slope In a relationship of slope to parallel and perpendicular lines, if two lines are parallel, we know that they must have the same slope. So the slope for both of those lines is 2, or -2, or 1, or they both have the same slope. And if lines are perpendicular, then they have opposite reciprocal slopes. And it can't be just one or the other, it has to be both. So an example for that would be, if for one line m would equal -1/2, for the other line, for them to be perpendicular, that would mean the slope would need to be 2. So it makes this right angle, and we see that the slopes are opposite and reciprocal.